Okay, hello everyone. I was asked to make a video on how to do some calculations in the post lab, and so here I'm going to show you very quickly. So the first thing we want to pay attention to is the fact that this is the chemical equation that we're dealing with. We have some HCl reacting with our NaOH. It's going to produce water and NaCl. Obviously this doesn't matter because they're going to dissociate into solution, and so we'd be looking at this specifically. But regardless, we see that everything is a 1-to-1 mole ratio. So that's going to be good. That's going to be useful for later. The question, though, is now that we've done all the experiments, how do we calculate the molarity of HCl? So the molarity of HCl is ultimately calculated with this equation here. Right? We need 4 different factors. The first one being the molarity of the NaOH that we got from the previous experiment, the one with the KHP. It should be somewhere around 0.1. So whatever you guys did for the titration with the burette, that's what you're going to use for this number. It should be about 0.1. Next, this number here, the milliliters of NaOH, that's what you're going to use your graphs. And so what you want to look for in your graphs ultimately is you want to look for this graph and try to identify a point right in the middle of this vertical part of the graph. That's going to be approximately the volume of NaOH that you added. And then you do this graph, your first derivative. Again, the bottom axis should be the volume of NaOH added. So try to estimate that where that number crosses the x-axis. Where is this peak on this axis? And similarly for the second derivative, you want to look at during what volume does the peak go up and down? What is the point in between those two peaks? Right? And so to get this value here, you need to kind of estimate what that volume that you dispensed is, and you have to use all 3 graphs to do that. So do keep in mind that's there. This is the 1-to-1 mole ratio, which is literally here, 1-to-1, 1-to-1. And at the end, you're going to divide by 0.005 liters, or the 5 milliliters of HCl that you added into your flask. That was told in the manual. So that's part of your lab manual. Together, you're going to get an mHCl. Then you want to take the average of the 3 trials. So take average. Calculate then the standard deviation of your data. And then find the 90% confidence limit. And so this is what I've been done before, which you'll find that in the index on how to do that. I do want to go over really quickly how to do the Excel to find the milliliters of NaOH used. All you're going to do is put this equation, literally put this equation onto Excel, then put this equation onto another column, this one into another column, and that one into another column. And so essentially what you're doing is what I showed you. You're trying to create those graphs. And where the numbers first come from is you're going to take the numbers you got from lab that you took a picture or you wrote down and literally put them out on your Excel. And that's going to take a lot of time, but that's what's going to have to happen. Put that all on Excel. And then you're going to take the first derivative, or the volume M, which is literally just the 2 volumes next to each other, and then divide that by 2. And keep going down the list. And I already showed you that there's a little, on the Excel square, after you put your number, there's like a little square here on the bottom. Literally drag that with your mouse down, and that'll populate all your cells. So you don't have to keep doing that over and over again. You can just press that little button on the bottom right, and it populates all that information for you. Same thing for D1, which is your derivative 1. There's your volume difference, and then your derivative 2. And then at the end of the day, what you're really trying to do is trying to fill out this table. And that's it. That's how you do this post lab. If you do need more help, just email me. All right.